Welcome back to my class. Today in this video I am going to explain zero hour knapsack problem, so which we can solve by using dynamic programming. So before going to solve this problem, just I'll give you some definition information about dynamic programming. After that I will show you how we can calculate solution for zero hour knapsack problem. So generally, if you compare a greedy method with dynamic programming, greedy method was straightforward approach. There we calculated the solution straight away, but there is no guarantee of getting optimal solutions. But here this dynamic programming is giving assurance of getting optimal solution. Now why? Because by using dynamic programming we can make a sequence of decisions. So under those sequence of decisions we can select one particular sequence that leads to optimal solution. Okay, but ultimate aim of zero or one knapsack problem or a greedy knapsack problem is to calculate the solution in terms of x1, x2, so on, xn. Suppose if number of elements or items in the given problem are n, then we are supposed to calculate the solution of all n elements in terms of x1 to xn. So x1 to xn is either 0 or 1. So x1 may be 0 or x1 may be 1 according to dynamic programming, or x2 may be 0 or x2 may be 1, so on, xn may be 0, xn may be 1, unlike greedy. But in greedy x1 we have already seen x1 is lying in between 0 and 1, but here xi is lying in between 0 and 1 in greedy method. This is in greedy, but in dynamic programming xi is either 0 or 1. So the solutions of x1 to xn are either 0 or 1, means either we consider the given items in the problem completely or we omit the item completely. But in greedy, where we can also select the fractional value, but there with the slight modification only we get optimal solution. But greedy is following the straightforward approach, but in those straightforward approaches we cannot sometimes we cannot get optimal solutions, but there is a guarantee getting optimal solution using dynamic programming, because dynamic programming is making sequence of decisions. Dynamic programming is making sequence of decisions. Out of this sequence, which selects one sequence as optimal, means we are calculating all the possibilities. Here we are checking all the possibilities. Out of all these possibilities, we are going to select one possibility as optimal sequence. So that's why there is a guarantee in getting optimal solution under dynamic programming. Now with this concept I am going to explain this knapsack problem. Here the solution required is x1, x2, x3. So x1 is the first item solution, x2 is the second item solution, x3 is the third item solution. But the solution may be either 0 or 1. Either we consider first item completely or omit item completely, like that. Okay na? So that's why this problem is called as 0 or 1 knapsack problem. We know what is knapsack. Knapsack is a bag. So here we are going to select one particular item and we are going to put that particular item into knapsack, so that if you select first item, then the bag is occupied with 2 kgs or 2 units of weight. From that we get 1 unit profit. But here under this particular problem, we have already seen in the greedy, our ultimate aim is maximizing the profit, and we need to fill the bag completely. So with this concept I am going to explain this problem now. So under this problem, we are going to construct sets now. So initially we start with set as 0, 0, because first one is treated as a profit and second one is weight. Or we can consider first one as weight, second one is profit. So initially we have not yet selected any item. So that's why initially set value is 0. Okay na? So generally we take profit and weight pairs. PAWI we are supposed to take. So that's why there is no profit if you don't consider any item. Okay, so here we are going to calculate all the sets, initializing with 0, 0, and based on number of elements. Here number of elements are 3, so that's why we need to calculate S1, S2, S3. But for calculating S3, we are going to construct the intermediate result, and after calculating intermediate result, we are going to combine S0 and intermediate results before calculating S1 for getting S1. And again we need to calculate intermediate result here based on S1 result. This intermediate result and this one, that intermediate result notation is S11, and this S11 and S1 are going to be combined each other to obtain S2. Again here we need to calculate S21, and this S2 and S21 are unionized, it's combined, and for producing S3. So our ultimate target is calculating S1, calculating S2, calculating S3, but directly you cannot get S1, S2, S3 from S0. So first calculate S01 and combine these two for obtaining S1, and calculate S11 from this and combine these two for obtaining S2, and again calculate intermediate result S21 and combine S2 and S21 for getting S3. But I will show you how we can calculate S01, S11 and S21. Okay. Now initially take S0 as 0 comma 0. I told you what is S0. Before start selecting the items, we are supposed to start a set with S0. So there is no profit, means there is no element considered. Now calculate S01. How can you get S01? Just simply add P1W1, P1W1 to all the pairs in S0. All the pairs in S0. Then what is S01 now? What is S0? 0. So 0 plus what is P1? 0 plus 1, comma 0 plus W1. 0 plus what is W1? 2. So this is the pair we get. Then we get 1 comma 2. Then we get 1 comma 2. So from these two, from S0 and S01, we can calculate S1. How can you get S1? Simply unionize S0 and S01. What is S0? 0 comma 0 is S0. Union. What is S1? 1 comma 2 is S1. So after combining these two, we get 0 comma 0 comma 1 comma 2. So this is S1. How we got S1 now? From S0, just add all the pair and weight items with P1 and W1. For obtaining S01, add P1W2 to P1W1 to all the items in S0. Okay, after getting intermediate result S01, simply combine S0 and S01 by performing union between, because these two are sets. S0 is one set, S01 is another set. If you combine these two sets, we get S1. So S1 is S0 union S01. S0 is 0, 0 union. S01 is 1, 2. Because after adding P1, W1, P1 is 1, W1 is 2. 0 plus 1 and 0 plus 2, we get 1, 2. So after combining these two, we get 0, 0, comma 1, 2. So this 0, 0, comma 1, 2 is S1. Now, after getting S1, for obtaining S2, we are supposed to calculate S11. How can you get S11 now? Just add P2W2 to S1. P2W2 to S1. Once you add P2W2 to S1, we get S11. So after there are so many notations we can use this as S11, this as S21, this as S31, whatever the way you can represent. But ultimately we need to add the respective profit and respective weight to the previous set for obtaining intermediate result. After getting intermediate result, then simply combine previous full set with the intermediate set. We get the respective set. Now this is the calculation of S1. In this way, we can calculate S2 and S3. I will show you how we can calculate S2 and S3. S2 can be calculated from S1 and S3 can be calculated from S2 just by calculating the respective intermediate results. Okay. So while calculating the sets, we are supposed to apply discarding rule, or we can call it as parsing rule. Parsing or discarding rule. So what do you mean by parsing or discarding? So once after calculating effective set from the intermediate set and previous set, we are supposed to apply discarding or parsing rule. So discarding or parsing rule means, suppose if we take two pair of items P1, PIWI and PZWJ, PIWI and PZWJ. Suppose if the condition is like PI less than or equal to PJ and WI greater than or equal to WJ. See here. So first pair profit is less than or equal to second pair profit, but first pair weight is greater than or equal to second pair weight. In this case, we say that first pair is dominating second one. First pair is dominating second one. So this pair is, if the pair is dominating, simply we are deleting this pair. We are going to delete the pair. Okay, na? Because according to Parsing rule. So that's why we can also call it as dominance rule. Because first pair is dominating second pair according to this particular relationship. So that's why, so by using this, we can discard the pairs from this particular set. And another one is, suppose if weight of the any pair is greater than the knapsack capacity. Here capacity is 6 units. Knapsack capacity is 6 units. If any pair weight is, so it means second item is crossing 6, then we are directly removing that particular pair from the set. Okay, na? So that is one way, and another way is just by applying parsing rule, we can discard the items. But here, once after calculating S1, because S0 is containing only one pair, there is no need of applying discarding. But in S1, once after calculating S1, assume this is Pi, this is Wi, this is Pz and Wz. Now 0 is less than 1. And 0 is, so here profit is less than second item profit, first second pair profit, and weight is also less than second item weight, or second pair weight. Then this is not dominating. So no need to delete that particular pair. Now I am going to calculate S2. How can you calculate S2? First calculate S11. This S11. How can we obtain S11? Just add P2 W2 to all the pairs in S1. All the pairs in S1. Then I can get S11 as pair is 0 plus what is P2? P2 is 2. 0 plus 2. 0 plus 2 comma again 0 plus 3. 0 plus 3. This is first pair comma second pair is 1 2. Then add P2 W2 to 1 2. What is P2? P2 is 2. So 1 plus 2 comma 2 plus 3. 1 plus 2 comma 2 plus 3. Then what we get? 2 comma 3, 2 comma 3, 3 comma 5. What we did here? Just add P2 W2 to all the pairs in S1. What is P2? P2 is 2, W2 is 3. So 0 plus 2, 0 plus 3, 2 comma 3. Then 1 plus 2, 2 plus 3, 3 comma 5. Then how can we get S2 now? Just simply combine S1 and S11. What is S1? S1 is 0 0 comma 1 2 union 2 3 comma 3 5. 2 3 comma 3 5. Then if you combine these two sets, we get, just simply write all the pairs in the order. 0 0 1 2 2 3 3 5. Once after constructing a pair, once after constructing a set, again apply discarding rule and parsing direct discarding rule. If any pair weight is greater than 6, no, because this is 0, this is 2, 3, 5. Still, all the second items in each pair is less than 6. So no pair is going to be deleted according to straight approach. Then second one is discarding rule. So compare each and every pair with all other pairs in the set, and if this particular condition is true, then immediately remove such pairs. So 0 less than 1, 0 less than 2. No need to delete 0 0. So this is less than all the pairs. Then 1 less than 2, 2 less than 3. 1 less than 3, 2 less than 5. No need to delete it. Then 2 less than 3, 3 less than 5. So up to this is safe. So all the pairs are safe up to S2. Okay, na? So this is about calculating S2. So we got S2 calculation by combining S1 union S11. Now I am going to show S3. So we can get S3 by adding P3 W3 to all the pairs in this set. After getting S3, again apply same concept. Just directly apply direct approach for deleting the items. And second one is discarding rule. Okay, so according to discarding rule, remove some pairs. If possibility is there, removal possibility is there. And according to direct approach, what is direct approach? If any second item if any pair second item is crossing 6, because those pairs are not at all valid pairs here, because no pair should cross, the weight value of that particular pair should not cross 6. So such pairs are directly removed, and according to this also we remove some pairs. Whatever the remaining pairs, from those pairs we can construct the solution. Okay, for calculating S3, now consider S2, and add P3 W3 to all the pairs in the set. P3 is 5, W3 is 4. Then add 5 and 4 to all the items. So 0 plus 5, 0 plus 4, 1 plus 5, 2 plus 4, 2 plus 5, 3 plus 4, 3 plus 5, 5 plus 4. So okay, after adding, we get 5 comma 4, 6 comma 6, 7 comma 7, 8 comma 9. How can you get S3 now? Just combine S2 and S21. So after combine, so what is S2? This one is S2, and S21 is this one. So after combining, we get 0 0 1 2 2 3 3 5 5 4 6 6 7 7 8 9. Now I have already told, once after constructing a particular set, now apply two methods for discarding the sets, discarding the pairs. First method is actually the capacity of knapsack is 6 units. So if any pair capacity is greater than 6 units, then simply remove those items, those pairs. See here, this pair capacity is 7 units, weight is 7 units. This pair capacity is 9 units. Then we can directly discard these two pairs. Next one is now apply parsing or discarding rule. According to discarding rule, compare each pair with each and every pair, other pair. So 0, 0, 0 is less than 1, 0 is less than 2. So this is safe. Because 0, 0 is less than, this profit is less than all the profits in the set, and weight is also less than all the weights in the remaining pairs. Then 1, 2. Compare 1, 2 with 2, 3, 3, 5, 4, 4. This is also safe. 1 is less than 2, 3, 5, 6. 2 is less than 3, 5, 4, 6. No problem. Again 2, 3. So 2 is less than 3, 3 is less than 5. 2 is less than 5, 3 is less than 4. 2 is less than 6, 3 is also less than 6. Okay. Now compare 3, 5. Now 3 is less than 5. So profit is less than profit of this pair is less than profit of this pair, but weight of this pair is greater than the weight of this. See here, this pair is dominating according to parsing rule. This pair is dominating according to parsing rule. Then we can also remove this. Then whatever the remaining items, we are supposed to maintain those items as S3. Now what is the resultant set S3 now? 0, 0. Resultant S3 is 0, 0, 1, 2, 2, 3. Anyway, 3, 5 is discarded according to parsing or dominating rule. And 6, 5, 4, 5, 4, 6, 6. Now this is S3. Okay. So after calculating S3, after calculating all the sets, starting with S0, calculating S1, S2, S3, based on number of elements. If number of elements are 3, we are supposed to calculate S3. If number of elements are 4, we are supposed to calculate S4, up to S4. Okay. Na? So after calculating S4, our ultimate target is showing that x1 is either 0 or 1, x2 is either 0 or 1, so on, xn is 0 or 1. x1 is the solution of first element, x2 is the solution of second element, and so on, xn is the solution of nth element. So here our target is calculating x1, x2, x3. So x1 is the first element solution, x2 is the second element solution, x3 is the third element solution, but solutions are either 0 or 1. But here we are starting solution construct from backward. We start with S3, means x3. We start with x3 and say that either x3 is 0 or 1. So based on this result, we go to previous set, and so because we start at, for solution construction, we should start at S3 and finalize what is x3. Then go to S2 and calculate x2 value, and go to S1 and calculate x1 value. So I will show you how we can decide either x3 is 0 or 1, or x2 is 0 or 1, or x1 is 0 or 1. I will show you how to construct a solution now. Okay. Now these are the sets available now. We started with S0, calculated S1, S2 and S3 based on number of elements. Suppose if number of elements are n, we are supposed to calculate up to Sn. Okay, na? Now start constructing solution from Sn. Sn produces solution for nth item, then means Xn. But we have only 3 items. Then start with S3. Start with S3 and calculate what is X3. Now I will show you. Now in this particular S3, select the maximum profit related pair. Maximum profit related pair. The maximum profit related pair is 6. Now we finalize 6, 6 is the optimal solution now. Okay, 6 is the maximum profit we can obtain, and from this particular one, the bag is filled completely. Now 6, 6 is the last pair in the last set. The concept is select last pair in the last set in the remaining pairs. Now from this particular pair, start constructing solution. Now I will show you how we can construct a solution now. Now we have selected 6, 6 which is belonging to S3. 6, 6 which is belonging to S3. Immediately verify whether 6, 6 is belonging to S2 or not. What is S2 items? 0, 0, 1, 2, 2, 3, 3, 5. No, this is doesn't belong into 6, 6 is doesn't belong into S2. Means on S2 something is happened. We got 6, 6. On one particular pair, we added P3 W3. So for then only we got 6, 6. Means something has happened on S2. Means some effect is happened. Some changes are happened on S2. So that's why we take X3. We consider X3 as 1. See, just carefully observe here. So select last pair in the last set. Select last pair in the last set. Which is, now here our set is last set is S3. Last pair is 6 comma 6. Now 6 comma 6 is selected from S3 and verify that whether 6 comma 6 is there in S2 or not. If 6 comma 6 is there in S2, simply solution is 0 because nothing has happened on S2 because the same pair is we obtained in S3 also. But here what happened? 6 comma 6 is not there in S2. Means one particular set, on one particular pair, we added P3W3. After adding P3W3 to the respective pair, then only we got 6 comma 6. Means some changes happened on S2 for obtaining S3. So that's why we made X3 as 1. X3 as 1. Okay, na? Then immediately subtract P3W3 from 6 comma 6. What is P3? P3 is 5. So 6 comma 5 and 6 minus 5 and 6 minus 4. Which pair we get? 1 comma 2. This 1 comma 2 should be belonging to S2 because this 1 comma 2 for this 1 comma 2 is there in S2. For this particular 1 comma 2, after adding P3W3 to this, P3 is 5, W3 is 4. After adding P3 to 1 and W3 to 2, we got 6 comma 6. So immediately subtract P3 from profit in the selected pair and W3 from weight in the selected pair. Now we got 1 comma 2. So this 1 comma 2 is belonging to S2 now. 1 comma 2 is belonging to S2. Immediately verify, same concept. After selecting 1 comma 2 in S2, verify whether 1 comma 2 is there in S1 or not. What is S1? Yes, 1 comma 2 is there. 1 comma 2 is there. Then immediately make X2 as 0. Suppose if the selected pair is already there in previous pair, selected pair is also there in previous set, then make solution as 0 because same 1 comma 2 we got. 1 comma 2 is there in S2. Same 1 comma 2 is there in S1. Then no changes happened on S1. That's why we got X2 as 0. See, remember one point here. After selecting pair, if the same pair is there in previous set also, then the respective item solution is 0. Otherwise, the respective item solution is 1. Then immediately subtract the respective profit and weight from the selected pair. Then only we make the X3 as 1. Now, okay. Now 1 comma 2 is also belonging to S1. Okay. Now after making X2 as 0, the same pair we start with S1. Okay, na? Initially we started at 6 comma 6. That pair is not there in S2. Immediately we made X3 as 1. Then after subtracting 6 comma P3W3 from 6 comma 6, we selected 1 comma 2. Now we started here at 1 comma 2 in S2 for calculating X2 solution. Immediately we verified whether 1 comma 2 is there in S1 or not. Yes, 1 comma 2 is also present in S1. Then immediately we made X2 as 0 because the selected pair is already also there in previous set. Then respective item solution is 0. That's why we made X2 as 0. Now again start 1 comma 2 in S1. Start 1 comma 2 in S1 and again verify whether 1 comma 2 is there in S0 or not. 1 comma 2 is there in S0 because previous set of S1 is S0. 1 comma 2 is not there in S0. Then immediately make X1 as 1. Okay. Now what is the solution now? What is solution? X1 equal to 1, X2 equal to 0, X3 equal to 1. Okay, means the first item is completely considered, second item is omitted, third item is completely considered. Now what was the last pair in the last set? 6 comma 6. Now we need to verify whether we get 6 comma 6 or not. Okay, na? So how can we calculate the total profit obtained by this problem? Just simple expression is PIWI. And total weight occupied in the knapsack is PIXI. XI is the solution. WIXI. Okay, so P1x1 plus P2x2 plus P3x3. That is the total profit we obtained from this problem. And total weight occupied in the knapsack is W1x1 plus W2x2 plus W3x3. We need to cross check them. What is P1? P1 is 1. What is x1? X1 is 1. So 1 into 1. 1 into 1. Now I will show you the solution. So what is summation of PIXI? This is the total profit we obtained. That profit should be same as the last pair profit. So what is P1x1? P1 is 1, x1 is 1. Plus what is P2? P2 is 2, x2 is 0. P3 is 5, x3 is 1. So 1 into 1 plus 0 plus 5 is equal to 6. Now profit is matched. Profit, this is matched. Then what about weight? Summation of WIXI. W1x1. What is W1? 2 into 1 plus 3 into 0 plus 4 into 1 because x1 is 1, x2 equal to 0, x3 is 1. 2 into 1, 2 plus 0 plus 4, 6. So these two must be matched with the last pair which we have selected for constructing solution. So in this way we can calculate the solution for any given knapsack problem with any number of elements. So in this way we are supposed to follow. If number of elements are n, we are supposed to start with s naught and we need to calculate s1, s2, s3, so on sn. But solution construction starts from backward. So start with sn and select the maximum last item in the last set after applying discarding and parsing and normal deletion rule, and verify that that pair is there in previous set or not. If that pair is there in previous set, make the respective solution of the item as 0, otherwise make it as 1 and subtract p and n from the selected pair and go to that pair and verify that that pair is there in previous set or not. Apply the same concept for constructing the solution of all the items, even number of items, any number of items you consider, and any number of items related weights and profits are given. Just simply follow this particular approach for calculating solution. So for this particular problem, solution is x1, x2, x3 are 1, 0, 1, and finally we got 6, 6 as the profit value and weight value we can obtain from this problem. Thank you for watching my video.